Welcome to the deep dive. Today we're jumping straight into a pretty high-stakes meteorological assessment.
We really are. We're looking at a huge area, Europe, Western Russia, the Caucasus.
And a very specific window, November 28th to December 7th, 2025.
That's right. And the top-line assessment is, well, it's high-moderate risk, but that doesn't really tell the whole story.
What's the real story then?
The risk is concentrated. It's all about a 10-day window, with the worst of it projected for November 29th to December 3rd. The reports are calling it a collision zone.
A collision zone. And this seems to have caught some forecasters by surprise.
It did. The initial seasonal models pointed to a more moderate, sort of evasive winter pattern, but they were just overwhelmed by what we're now calling a triple threat.
Okay, let's unpack that. This triple threat, what are the three atmospheric drivers that are all aligning at once?
So first, you've got the global background. There's a weak La Niña event that's just persisting in the Pacific.
Right, and historically that tends to set a colder stage for European winters.
It does. It primes the pump. But the real drama, the trigger, is an unusually early, sudden stratospheric warming event, an SSW.
And the SSW is what disrupts the polar vortex.
Exactly. It's leading to a major disruption, potentially a full collapse of the vortex. And that just lets all that ferociously cold air spill south.
So that's the freezer door flying open. What's the third element?
The third is how those first two sync up. They force the atmosphere into a deep negative phase of the Arctic and North Atlantic oscillations.
The AO and NAO APU.
Right. And that's the delivery mechanism. It forces the jet stream into this deep, loopy north-south flow. So it drags that frigid air west and then steers these powerful wet storms south.
Toward the Mediterranean and the Black Sea.
Precisely.
So you have this blast of Arctic air. But it's not moving into the Europe of 50 years ago. It's the fastest warming continent on the planet.
How does that change things? That's the critical link. This is where climate change becomes an intensifier, a threat multiplier.
How so?
You have anomalously warm sea surface temperatures all across the North Atlantic and the Mediterranean.
So a lot more moisture in the air.
A huge amount of surplus moisture and latent heat. It's fuel. So when that polar air, truly frigid air, crashes into that supersaturated warm air mass,
You don't get light, fluffy powder.
you get the opposite. You get heavy, high-density wet snow and severe icing. It's a textbook case of thermodynamic forcing that just maximizes stress on infrastructure.
Let's translate that stress into specific threats. For Western and Central Europe, what's the number one danger?
Flash freezing. The cold air is going to move in so fast over ground that's already soaked with rain. The danger is that rapid phase change.
So instant black ice on major roads?
A really dangerous widespread black ice scenario, yes.
Yeah.
Severe freezing rain.
And then for Western Russia, where the cold is more entrenched.
There we're talking sustained blizzards, but also a high risk of these damaging rain-on-snow events.
Rain on snow.
Yeah, moisture from the Black Sea gets pulled in and falls as rain on an existing snowpack. It makes the snow incredibly dense and heavy. That's what collapses roofs and brings down power lines.
But the assessment flagged one region with the highest relative risk.
It did, the Caucasus.
Yeah.
Because that jet stream flow basically acts like a fire hose, channeling these storms directly into that complex mountainous terrain.
And in the mountains, the dangers multiply.
Oh, absolutely. You have to plan for cascading hazards. We're talking extreme snowfall, which can then lead to landslides, flash flooding, and of course, a severe avalanche risk, all hitting at once.
So if we synthesize all this, what we're really seeing is a persistent cold signal from La Niña, a sudden dynamic trigger with the polar vortex collapse, all amplified by a warmer, wetter world.
It's the convergence. That's what defines the hazard. This early winter event becomes unusually destructive because all three elements are hitting their peak at the same time.
It's a powerful combination.
It is, and it leaves me with a final thought for you to consider. We're so accustomed to planning for what you might call dry cold or average winter volatility, but this event is a high moisture, intense cold collision. So the real question is, how does our approach to structural resilience, to urban planning, need to fundamentally change to handle that kind of threat? It's an entirely different preparedness strategy.